Okay, so here in example 77, we actually want to go through this process and actually compute the areas and see how it approximates. By the way, I can tell you that the area is actually 1/4 here. So this is the function x cubed, and I'm not telling you how to figure out the exact area under this yet. Remember, it's a limit as the number of rectangles goes to infinity. But the area, if I told you how to do it, we could actually figure out to be the total area under this curve, f of x equals x cubed, from x equals 0 to x equals 1, comes out to be 1/4, or 0.25. So I just want you to have that in your mind as we compare this, as we go through and look at the different ways of doing it with just a set number of rectangles. So we're going to do a lower sum with 4 rectangles. Lower sum means they're all going to have a height that's inside or less than the actual height of the function. So this doesn't look like 4 rectangles, but it is. There's a rectangle from 0 to 1/4, from 1 to 1/4 to 1/2, from 1/2 to 3/4, etc. But of course, if I'm taking a lower sum, there's no height for this rectangle, so the area of that would be 0. Now, the base of each of these rectangles is 1/4, right? From 1/4 to 1/2 is a fourth, from 1/2 to 3/4 is a fourth, from 3/4 to 1 is a fourth. And the height is always going to be the left endpoint here. So it's going to be f of 1/4 is the height of the second rectangle, f of 1/2 is the height of the third rectangle, and f of 3/4 is the height of the fourth rectangle. The height of the first rectangle is f of 0, which is 0, right? So there's the area of the first rectangle, 0. And the second rectangle is height times base, f of 1/4 times 1/4. Third rectangle is height times base, f of 1/2 times 1/2. And the fourth rectangle is height times base, f of 3/4 times 1/4. So you have to work all this out. Now f of 1/4, remember f of x is x cubed, so 1/4 cubed is 1/4 cubed here, which is 1/64. F of 1/2 is 1/2 cubed, and f of 3/4 is 3/4 cubed. So you work those numbers out, you get 1/8 and 27/64. The idea is combine this all into one fraction, simplify. It comes out to be 36 over 256, or 9 over 64. That's exact, and if you put that in your calculator, it's about 0.1406. Certainly much less than 0.25, and you can see that visually, the error here. All right, now let's do an upper sum. The upper sum means that we're going to take 4 rectangles, but they're going to have more area than actually what's under the curve, okay? So then I will actually see the 4 rectangles here. So the first rectangle, its base is 1/4. All the bases are 1/4, right? The height of the first rectangle is f of 1/4. The height of the second rectangle is f of 1/2. The height of the third rectangle is f of 3/4, and the height of the fourth rectangle is f of 1. So those are the heights of each rectangle. And again, you work all that out. You combine this into one fraction and simplify. It's 25/64. Which you plug that into your calculator, is 0.3906. So again, that overshoots it. Remember, the exact area is 0.25. And I haven't told you how to find the exact area. I'm just telling you that so you can see what's going on with our numbers. All right, now let's do one where we take the midpoint. Okay, so now we're going to overshoot and undershoot, kind of, right? And hopefully get some of these errors to cancel out. So the midpoint of the first rectangle's base would be 1/8. So the height of that rectangle would be f of 1/8 times its base, which is 1/4. The midpoint between 1/4 and 1/2 is 3/8. So the height of that second rectangle will be f of 3/8. The midpoint of the third rectangle's base is 5/8. So the height of that rectangle we're going to take as f of 5/8. And the midpoint of the fourth rectangle will be at 7/8. So the height of that rectangle will take as f of 7/8. And you can see that's right here. Adding up the area of the 4 rectangles, work it all out. It's just some arithmetic at this point. Get it into one fraction, 496 over 2048. Put that in your calculator, see it's 0.2422, which again, it is a lot better, a lot closer to 0.25, because you get some area that's overshooting, some that's undershooting, and they kind of tend to cancel each other out a little, but it's still not exact. Okay, so that's the idea behind using rectangles. And again, you can imagine if I let the number of rectangles go to infinity, I could have a hard time adding up an infinite number of areas, but the idea is that it would become 0.25, the exact value.